Today we are going to talk about three dimensions, three space. Okay? So we're basically plotting coordinates that are x, y, and now z. Okay? What's an example of something that we consider three space? Okay. This room. We're sitting in three space, right? We are three-dimensional objects, right? Sitting in space. Okay? So instead of just an x and y axis, we have an x, y, and a z axis. Okay? This is the x-axis. This is the y-axis. And this is the z-axis. So we have three planes that are breaking up this three space for us to plot coordinates. Okay? So we have our xy plane that we can think of as like the floor. And then we have the z-axis coming out of it. Okay? We have three planes. We have the xy plane, the yz plane, and the xz plane. How many divisions do we have amongst our space? In a plane, we have 4 quadrants. We have 8 octants. Okay? So just like in our xy plane, wherever everything is positive, that was quadrant 1, right? Same thing here. Where x, y, and z are all 3 positive, we have octant 1. And then we're going to move above the xy plane counterclockwise. So this is octant 1. And then we move back to where x is negative, that's octant 2. We move over to where x and y are negative, that's octant 3. We come forward to where x is positive, octant 4. Okay, and then we're going to do the same pattern.
4 octants are pretty much the same as on the xy.
Yes. Then we're going to go where z is negative, 5, 6, 7, 8, in that same pattern for our other 8 octants. If you would like to turn in your books to see a visual of each one. On page 812, there is a picture of each octant highlighted. Okay, graphing three-dimensional figures on a 2D piece of paper, okay, on a plane is difficult. So I'm going to let the book give you those. Okay, on 812 at the bottom, there are each of those octants. So you can see we start in that octant where everything's positive, and we move counterclockwise to name 1, 2, 3, and 4, and we go directly below for 5, 6, 7, and 8. Alright. Does that make sense? Okay. Now, my first hour was bothered by where the x, y, and z axes are. Okay. Sorry. This is how we're going to draw it. Okay. So just remember where the x, y, and z axes are, and make sure you label those accordingly. Okay. We are going to plot points. Now, I've given you a piece of 3D graph paper. Oh, this will help so much, okay? Last year I was doing it without 3D graph paper. I discovered this, and it makes life easy. So, these are the first 2 points we are going to use. So, okay. First of all, pick like a corner, alright? You don't want to fill up the entire piece of paper because you're going to want to save some for your homework, alright? But what you want to do is you want to draw your X, Y, and Z axes. So, you're going to pick a vertical line. Okay, why is half of my line negative, half of my line dotted? Okay, what I'm doing is where I start making it dotted, that's where it becomes negative. The solid is where we're positive. Alright? What axis did I just draw? Okay, then you'll pick this guy. What axis is that? And then you'll pick.
Why?
Alright. Alright. So, anytime we plot points, you want to move in your XY plane first, and then you're going to move vertically your Z value. Okay? Our first one's simple though. 3, 0, 0. Okay? 3 is which coordinate? X. So along our x-axis, we're going to move forward 3. I'm making these tick marks so you can see. You don't need to make those tick marks. They're there for you. Okay? And then y and z are 0, so there's our coordinate. Okay? This coordinate lies in 2 different planes. Who can name one of the planes it lies in?
X1.
It lies in the xy plane, and it lies in the xz plane. Any questions about that?
Which is the X coordinate and Z coordinate?
We always go in alphabetical order. Okay. Now let's plot 404. Okay, so we're going to move 4 along our x-axis, 0, we don't have to go anywhere, right? And then we're going to move up 4. So you notice from this point, there's a vertical line. Move up 1, 2, 3, 4.
Wait, that's also on the wrong axis.
Okay? What I want you to do is make dotted lines for your path. Okay? You move out this way, you move up this way. So how we are looking at it, yeah, it looks like that point is on the y-axis, but it is not. Okay, if I took this 3-dimensional figure and I turned it, okay, so we had a different aspect.
My eyes just don't look like that.
Okay, because you will have these dots, you will have these dotted lines describing the path of the point.
That really
Okay.
makes sense.
So that one's just on the Y or the X.
Yes, that one is on the XZ plane. Very good. Okay, so it's lying on this sheet of paper that's cutting through as the XZ plane. All right, let's try one where we don't have any zeros at all. So just give me a second to redraw my octants here. Okay, so when you graph to -3, 5, here is x is 2, -3 is here. So I'm going to make dotted lines that get me to that xy coordinate. And then we're going to take that coordinate and we're going to move it up 5. So up 1, 2, 3, 4, 5. So you can see that we moved the 2, -3, and then Is that better? These? So you can tell how far we were moved away from both the x and y axis. We know where we are on the x, y plane before we move it up. Without those dotted lines, you're not going to be able to figure out where at in the xy plane that point is above. Okay? Because we're graphing something three-dimensional on the plane. Okay? Now let's try negative 2, 6, 2. Okay, so negative 2, we're going to move backwards along the x-axis. 6. Okay, so we're kind of making a little parallelogram, right? Okay? It looks like a rectangle. We move in parallel motion with our axes, right? Just like we do on the xy plane. Okay, this looks a little different since we're at a different angle. All right, and then we're going to move this up 2. 1, 2.
Why did you not move the line from the y-axis to like right here?
Like both of these?
Yeah, I get why you have the longer one, but that's a short one.
So you can tell how far, so you know that this distance is 2. Okay, with this 3D paper, okay, it's maybe not as necessary, but I still want you to draw it in. Okay, just so you know, where are we coming from the x-axis, where are we coming from the y-axis, and put those together. Okay, next thing is distance. Okay. It's like the same thing. Okay, I'm going to cover this up. Without the z's, what is that formula? That's the distance formula in a plane. All we did is add in some z's, and now it's the distance formula in 3 space. Why is this the distance formula? Okay. I have 2 random points in 3 space. Now remember, this is in 3 space. Okay? So these 2 points, we're going to visualize them at 2 different heights and okay, like I'm going to make with my fist. Like we're at 2 different heights and we're not underneath each other. Okay? Now if they're underneath each other, we can easily find the distance, right? Okay? So they're at 2 different heights and they're not underneath each other. Okay? So that's what I want you to visualize with these 2 points right here. The direct path is representing the distance, correct? Okay. I am going to make a right triangle with these points. Sorry. Okay. Where this leg over here is representing the difference in our heights of the points. So how do I represent the difference of our heights? Okay? The difference in the z's. correct? Okay. Which means, what kind of distance am I talking about to find this other leg down here? We're dealing with y and x, but these 2 points, they lie.
Why?
They're not necessarily in the xy plane, but they're in the same plane. Okay?
Oh.
We could put a piece of paper through both of those points because they lie in the same plane. Well, if we have 2 points in a plane, how do we find their distance? The square root of x minus x squared plus y minus y squared, right? If I want to find the length of a segment in a plane, we have the distance formula, right? Okay, now look at this right triangle that I have here. To find our hypotenuse, Sammy, what are we going to use? Pythagorean theorem. Leg squared plus leg squared equals distance squared. Okay, leg squared gives me x minus x squared plus y minus y squared, because the square takes away that square root, plus leg squared, and then we square root both sides and we have our distance formula. That is why this formula, that yes, looks very easy to use, this picture is why it works. Okay? Some of you may not care as much as others, but this is why it works. Basically, remember the formula so you can find the distance between 2 points. Okay, so we have a coordinate, 419 and 216. So our distance, what do? Square root of 4 minus 2 squared. Does it matter which one comes first, the 4 or the 2? No, because we're squaring it. Okay? Plus 1 minus 1 squared plus 9 minus 6 squared. So we have 4 plus 0 plus
9.
So our distance is radical 30. Okay? You have 2 things to do in your homework. Plot points, maybe identify some octaves, and find distances. That is the lesson for today. Okay?